I'm Paul Galata, Senior Technology Specialist with Mouser Electronics. Welcome to Plugged In.
I'm Greg Smith, Business Development Manager for Amphenol Communication Solutions.
And I'm Matt Burke, Global Director of Sales for Amphenol RF.
Today we're going to be talking about industrial autonomous mobile robots. Welcome to Plugged In. Thanks for joining me, Greg and Matt. Hey, there's a lot going on in autonomous mobile robots. They're proliferating and expanding. Greg, can you tell me some of the factors that you think are behind this growth?
I think a lot of it has to do with labor shortages, labor costs, and really eliminating the manual process of the human element within the warehouse setting.
Matt, could you share some of the influences that you think are causing this?
Sure, I think there's, as always, the overall goal to find efficiencies and reduce costs that Greg is talking about, and I think these technologies are allowing us to do that. In addition to that, I think we've had the impact of the overall labor shortage as well as the COVID aspect, which has created needs that we haven't seen in the past and really expanded this online retail space really
Amazon,
considerably.
right? We're all shopping on Amazon.
100%, and that's really what's been driving a lot of this, and really taken what was a smaller warehouse sort of setting where you were just holding product and making it a distribution center, and you're seeing these pop up around the country. So the more and more of these that get added from these major retail places, or even a place like Mouser, that's how it's really going to drive this industry.
I imagine when we talk about an Amazon or a Mouser that shipping things efficiently and safely is really important. Greg, could you share a little bit about how you think robots are playing a role in that?
Yeah, excellent point. So everything in this environment has to do with efficiency and workflow. In this environment, we're looking to see how things can improve workflow and efficiencies, and I think a lot of the picking, the placing, and a lot of the transportation within the different cells in a warehouse setting is important to increase these efficiencies.
Well, we're talking today from Mouser, a big warehouse, and we're really focused on AMRs in the industrial space, whether it's a warehouse like what Mouser has or whether it's a factory floor with various goods and services moving around across the assembly lines, so to speak. Matt, could you share a little bit about what you think the industrial part of the application means and how that plays with autonomous mobile robots moving around in that environment?
Yeah, sure. I think as time goes on here, and we talked about the need and the drivers behind what's doing it, these different technologies need to be adopted. So you've got the GPS aspect of it, you've got the asset tracking, you've got telemetry for the equipment itself. In addition to that, you've got overall communication, so Wi-Fi, GPS, and then even at times RFID. So as all of these different technologies all come together in the warehouse space or the industrial space, if you will, that's really what's driving it.
Well, we're talking about industrial, and we're somewhere around 20 degrees C in our setting here, but I imagine besides temperature, there's a lot of things that go on inside a warehouse or inside a factory floor that might make it a harsh environment. Greg, could you share a little bit about what you see AMRs doing in the industrial context?
Absolutely. So there's things to consider like shock and vibration. Things may be falling, things may be moving, things are really paying attention to waterproof IP67 solutions and also eliminating a lot of the dust that's going on in this environment.
So everything that you do is focused on making sure that within the context of whatever the environment is, it's rugged and robust enough to stay working.
That's absolutely correct. We want to make sure that everything from an operational perspective is taking into consideration all the environmental aspects.
So Matt, we've talked a little bit about some of these harsh environments, but I know that we're in this environment of the industrial Internet of Things, where a variety of communications, whether they're wired or wireless, is going on. What are some of the important considerations we have to take in this realm for industrial Internet of Things?
Yeah, it's a really good point because you really do have two aspects. You've got the wired aspect, which is the internal components of the robots themselves, so the pickers and the placers and things of that nature, where you've got to have these wired solutions to allow it to do the motions that it's doing. In addition to that, it's the communication aspect and the telemetry aspect that we mentioned before, in that it needs to be able to go back and forth and know where it is and know what it's picking and know what it's placing. So this combination of these two different types of wired versus wireless are really coming together for the overall solution for the warehouse.
And you're making sure your solutions then on the RF are robust enough to ensure that no matter what the situation in the context is, it can withstand that.
Yeah, without question. I mean, there's a lot of customization that go into these types of product, and some of it might be a latching mechanism that there's. In some cases, it's key coding to prevent mismating of multiple connections within the same solution, and then sometimes it really is a ruggedization aspect of it. And then there are times when it's just the particular robot they have require a slightly different length or a different orientation, right angle versus straight, something like that, and we're able to provide all of those different versions.
Greg, I know we were just talking about what happens inside the robot. We got to be able to make assured positive connections. What are some of the types of solutions that you guys offer in terms of making connectors for power and signal?
Absolutely. So our solutions need to be adaptable. They need to be able to be polarized. So as Matt said, they're not being able to be mismated. A lot of the robust features like the hold downs are important so that the reliability is taken into consideration. And then the different architectures allow different form factors, different size connections, and really be able to be robust enough for the application.
So are there some specific things that you're doing that you could show me in terms of maybe making these positive type of assurance connections?
Yeah, so one great example is our microspace solution, which is a cabled solution. And this one in particular is a waterproof and also has the robustness of an active latch, as well as things like CPA and TPA terminology, which for TPA is what we call terminal position assurance and allows anti-backout for the cable. And then for the TPA, it's essentially a secondary latch to ensure that it can't be unmated accidentally.
Okay, and that's that red latch there?
Absolutely.
Yeah, so that works as it assures that it can't back out.
Correct.
Man, I want to talk to you a little bit more about this IIoT environment. We got this wired communication we talked about, but tell me a little bit about the wireless communication. What's going on with radio frequencies inside of a factory and a warehouse? What are some of those operating conditions and what's being deployed there that you see?
Well, we're really seeing an evolution of our products. For example, FACRA has been used for quite a while in the automotive space, and as that continues to evolve into what they call the mini FACRA, we're seeing that same thing in the automotive space, and it gives you a higher data rate than you normally would see and reduces latency within there. So as you can imagine, you've got all these robots moving around in unison together. You can't have them running into each other, and there needs to really be a network communicating, and that's being driven by this. So you're going to see that. In addition to that, you see the miniaturization of the solutions themselves as time goes on. So where here you have this single connection, you have basically the same architecture, but you can have four in
so
that
that's
same
the
area.
mini FACRA where I get four times as dense.
Correct, yes, and that pitch and that overall gang solution really makes a difference, and certainly for anyone who's building a board, being able to mount a single connector and have four connections, anyone who's dealt with coplanarity issues and things of that nature, this really makes life a lot easier.
Yeah, awesome. Hey Greg, we were just talking about the automotive industry, about how some of that's transitioning into the industrial space. Could you share a little bit about how some of those ideas are underway?
Yeah, so there's a lot of transition from what we know as U.S. car standard, which is mainly geared towards high shock and vibration. And a lot of our solutions, like our Bergstack family of products, allows us to be able to ensure that high reliability shock and vibration. So these solutions are able to transition from automotive into this harsh environment warehouse setting to be able to adapt and really be able to show the true reliability of the system.
Great. Now, Matt was mentioning how they have the mini FACRA, which is a more dense version. My understanding is that Amphenol is making industrial autonomous mobile robot solutions that are even more dense. Could you speak a little bit about what you're doing in that area with small pitches?
Yeah, so the key here, Paul, is to be able to understand the different challenges that you have within the architecture. So in a lot of cases, for the miniaturization, we go all the way down to 0.4 millimeter pitch. And a lot of the considerations for these type of connections is different stack heights, different position counts, different features within, you talk about alignment. In a lot of these cases, we're able to adapt to many of those considerations.
Gentlemen, I want to ask you, we're talking about autonomous mobile robots. They got to be able to see their way around. They got to be able to know where they are, to have this spatial awareness. Could you talk to me a little bit about what type of solutions that you have that gives this spatial awareness that helps make that all a reality?
Yeah, so a lot of cases we're providing solutions that are connecting to different, what we call general purpose I/O, which in a lot of cases are peripherals or sensors or camera systems that basically allow you to be able to see where in the warehouse setting that you're moving around and different interactions with other robots, and really be able to show the versatility of the system itself.
Matt, if you would, I want to go back to this IIoT and this wireless communication. Can you lay out for our viewers what are some of the common technologies being employed, and why would people use that in the industrial setting, and how those come to play with AMRs?
Sure, absolutely. I think in a lot of cases we're adapting existing technologies that we know work. Certainly there's been the ruggedization and miniaturization overall, but if you really look at the overall ecosystem, we're selling everything from the standard AMC board connector, which is an ultra miniature connector, all the way through the micro connector up to a traditional I/O, whether it be an SMA or a TNC or anything along those lines. So as this IoT space comes to fruition, it really is adopting current technologies and applying it where it makes sense.
So some current technologies are things like Bluetooth and Wi-Fi and 5G.
Yeah.
Could you share a little bit about some of those specifics and where you see
Sure,
them?
there's what you just talked about, right? And then in addition to that, you've got the GPS aspect, you've got the visualization aspect. We've had applications where they actually use it as a camera. So for example, a forklift driver could lift up to a top shelf and he's able to see on his heads-up display what he's looking at. So those sorts of situations and those sorts of products have really come to fruition. And then there's been some other developments. For example, we actually manufacture camera backs, which is something we've never did before, where the customer has the camera, we'll manufacture the camera back itself that has the RF connector built into it, so then they can just connect in and go from there.
So we've mentioned this camera and the spatial awareness, LiDAR and things of that sort. Talk to me about latency and about data rates and speeds that are involved with this. What are you guys doing there?
Sure, I think that's something that's going to become a bigger and bigger part of this. And certainly as 5G rolls out, it's going to enable quite a lot of this. So the overall frequencies of the connectors themselves are really being pushed to the limit. So a lot of our our camera connectors rather, are being pushed to get to like 20 gigabit per second. So very high definition, very high data rates to be able to do it, because from a safety perspective, latency can't work. And then certainly, as we talked about, you've got these orchestrated robots moving by each other. The timing of that is important. So if one is off kilter with the rest, you could have a collision or something of the sort.
I understand. Greg, we talked about higher density and some of those small pitches. Talk to me a little bit about any applications you have with sub-miniature type of packaging.
Yeah, so I think certainly with our products, versatility is important, and in miniaturization, I mentioned before the size of the connector. I think that's important in many cases where the main goal is to hold the biggest load with the smallest package size within the robot. So in a lot of cases, our product solutions are being able to adapt to different connections, different signal counts, different power requirements, and I think a lot of those have comparisons to automotive, as we talked about before.
I think another thing that I've heard that you're able to do is custom tailor solutions. Could you speak a little bit about your capabilities there?
Yeah, so one example that I have here is our combo stack product, which is traditionally actually a board-to-board product, but here we are putting it on a rigid flex, which is essentially cableizing it and allowing it to go over an extended length, if you will. So in a lot of cases, we can be very adaptive to the type of architecture within various different types of mobile robots.
As we close, gentlemen, I want to give you the opportunity just to say some parting words. I'd like to start with you, Matt. Would you share some final thoughts with our listeners?
Sure, yeah, I think this is really just the tip of the iceberg here. You know, as we look at these technologies and starting within the warehouse, this is going to continue to go out into the field to ultimately delivering to the home, but then within the home you've got smart home, you've got vehicle to vehicle, you've got all these different machine to machine type technologies.
So this is just going to expand.
Without question, and I think that's the exciting part from the radio frequency side specifically. You know, we have the broadest RF offering in the world, and for us to be able to bring that to the table and have Mauser stock that product for our end customer, I'm excited what comes next.
Me too. Greg, any last thoughts?
Yeah, I think in a lot of cases where we're just focusing on being able to adapt to the different environments. As technology improves, we want to be able to have the versatility with our products to adapt to those new technologies. Certainly robustness is important, and I think a lot of the terminology that we talked about today is important with latching systems and even the environmental aspect. So I think having a broad range of products to be able to adapt to the different technology is important to have.
Well, I want to thank you, Greg, and I want to thank you, Matt, for being my special guest today. Join us on our next episode of Plugged In.